If you produce electricity with a thermal power plant, you would just use the heat which is occurring via the CHP process for district heating or industry processes. So you have the first sector coupling from electricity to heat. And if you consider that the power should be green and the heat should be green, you're using hydrogen, producing hydrogen. You also have a conversion process producing heat. Using this again with heat pumps for district heating or also industrial processes, you have the second sector coupling, and the same hydrogen you can also use for mobility applications, so you have the third. So using sector coupling and energy security will go hand in hand and strengthen each other, so it's a good combination to go for.
If we talk about the energy mix, I think it will be much more electrical, because energy, of course, is heat and electricity and all the other energy that we are consuming. And I think it will turn really, really much more electrical, at least if we want to have any chance to achieve the decarbonization targets. And I see all the trends to go there. So I see the sector coupling between heat sector, industry sector, and electricity sector, that everything is moving, and transport sector, that everything is moving towards much more electricity. And this electricity will be provided, and I would say, well, at least if I look towards 2050, mainly by renewable sources. 2030, maybe not all there, but we are very good on that way. I mean, you have to replace a lot of energy producing assets that are really expensive, and they have a lifetime of 30, 40, 50 years. So they are not replaced instantaneously. But yeah, I think it will be all renewable. With some add-in of other technologies, of course, of storage. There will be some gas turbines still needed in that scenarios that I have envisioned. They may be running on synthetic fuels that are produced from renewable sources as well, because we need that buffer. And you will see the same electrification of the transport sector, electrification and efficiency increases in the industry and manufacturing sector. I think it is one of the strong contributors that we have today, because carbon capture is an available technology today. We can employ it large scale. So you can go to those big single emitters like a big power plant or a cement plant or another manufacturing plant. We can capture CO2 from there, and we can utilize or store it today. Yes, of course, politics may sometimes play a role why it's not possible in some locations, but I would say technology-wise, that is one of the big solutions that we have to significantly reduce CO2 footprint. And I mean, the technology is there to reduce down to 5%, maybe even below 5% of the emissions. Being in Germany, of course, a lot of people say, yeah, but what about the last 5%? Because we want to get everything right from the start. I say, let's do the 95% and then do the 5% in parallel. But start with those 90% reductions that are available today. And I think that would bring us a strong leap forward. So therefore, I think that the carbon capture will play an important role going forward for the short and mid-term. And maybe in the long term, we don't need it that much anymore. It may still be one technology if I look at 2050 and beyond, that it will capture the last 5% of emissions that we just can't get rid of, because we still need cement, and cement intrinsically has CO2 emissions when you produce them. So therefore there will be still something like carbon capture, but maybe on a different scale and different application as we see it today.
I think overall it's about the portfolio. So about different solutions that bring value for our customers to the table. On the one hand, we see rotating equipment like synchronous condensers that help integrating renewables. On the other hand, we have power electronic solutions like StatComs, and upcoming more and more battery energy storage as a solution.